So in terms of ash, the ash is restricted 5,400. In terms of these skilled craftsmen, they are only available for how many hours? 12,000. So we've got a second constraint, the labor hours. HC sells queues to a large market. Demand for the queues is strong, and in any period up to 15,000 pool queues and 12,000 snooker queues can be sold. So we've got another constraint. What is the constraint here? The other constraint is the demand. We cannot produce any number that we want. No, we are going to be restricted by demand for both the pool queue and the snooker queue. So the demand for this is another constraint. The selling price is 41 for snooker queues, for pool queues, and for snooker queues is 69. Now, do you remember how to set up our linear programming model? Do you remember how to set up our linear programming model? Now, the question here says, determine the optimal production plan for a typical period, assuming that HC is seeking to maximize. No, I've skipped something, isn't it? I'm supposed to start from here. Yeah, let's start from the first part of the question says, calculate the contribution from each type of the queue. So we need to get the contribution from the pool queue and the snooker queue. Then after that, determine the optimal production plan for a typical period, assuming that HC is seeking to maximize contribution end. Use a linear programming graph. Identify the feasible region and also the optimal point accurately, and calculate the maximum contribution that could be earned. Okay, so now let's get ready and set up our linear programming model.
Sir, I'd like to find out about the other part. It says that you should use a linear programming graph using the graph paper provided. Does that mean that during the exam, graph papers are provided? And do those papers come in form of soft copy or maybe?
In the current exam, you will not be asked to do this. In the current exam, you'll be asked to interpret. So this is the time when the exam was paper-based. So now you don't worry about that. However, for you to interpret, you must be able to draw. Without interpretation, without drawing, knowing how to draw, you can't interpret. Is that okay?
Yes, sir.
All right. You're happier now?
Very much.
Okay, fine. Now let's set up the programming model, everything, and let's get started there. So you must be drafting also somewhere. As we draft, you also draft somewhere, isn't it? Let's do that now. Yeah. So let me also prepare my Okay, so let's set up our linear programming model then. Let us go. So for the sake of our friends who may not have been around, but also for you to reinforce, let's go through the steps. Let's go through the steps. Step number 1. Please help me define the distinct variables. Help me define the distinct variables, please.
Let P represent the pool cues and S the snooker cues.
Excellent. Well done. Well done. Let P represent units. That's the only word you forgot there. That's units of pool cues to be produced. Okay, good. And let S stand for what? Represent what? Units of what? Snooker cues, right? So Brenda, that's how we set up a linear programming model. You can pick something. I know I'll do this with you again, but you can pick something. So that is the first item. The idea is when you are writing a report, when we find P and S, they are no longer letters in the English alphabet. No, they represent units of P and S to be produced and sold. Step number 2. Step number 2.
The objective function.
Excellent. We established the objective function. Now the objective function, we have been told that our objective is to maximize what? Contribution. And we are not surprised that here the question says calculate the contribution to be earned. So let's calculate the contribution to be earned. Now we have got the selling price and we've got the costs. Okay, so let's do a small working here. Let's do a small working together here. Let's go. Okay, so the product that you have is the S, the P, and the S. Okay, let's look at the costs. What are the costs? Help me with the cost. Labor. What is the labor rate? Let's pick it's 18 per hour. So 18 multiplied by 0.5 and 18 multiplied by 0.75. So I come in and say labor. So what's the labor cost, people? Can you give me the labor cost? Under P, what do I put? 18 multiplied by 0.5. Yes. What of the other one? 18 multiplied by
18.5.
Yes. Good. Let's put another item. Ash, or the material. Material. In management accounting, we just call this material. What is it? 270 grams, 270 grams. Let's look at the price. Where is the price? 40 per kg. Now there's an issue here. This is kg, this is gram. How do you convert a gram to kg, people? 270 grams. We divide this by what? 1,000.
1,000.
Excellent. So in terms of kg, this is 0.27. Okay. So go here, you say equals 0.27, eh? Multiplied by 40. And the good, even there is the same. What of the variable cost? 120 and 470. There we are. So what's the total variable cost? We are management accountants, must be experts in presenting information. Total variable cost, we are experts. This is our expertise. Huh? Yeah. Okay. Selling price. Let's pick the selling price. The selling price is, the pool cues is 41, the other one is 69. So 41 and that one 69. So with this information now, people, what is our contribution per unit? Contribution per unit, that less that. And here, there we are. This is your contribution per unit. Good. Now we can, with this information, as Jesse told us, we can now go back and complete our objective function. So what is the objective function? 20 and 40, isn't it? So objective function is to maximize C equals 20P plus 40S. Now, as Jesse asked that, Mr. Peter, are going to be expected to draw this in the exam? No, but in the exam, when you find this, you must interpret. When they give you an objective function, you must interpret. Now, you cannot interpret if you have not established a constraint for the objective function for yourself. But now you can easily tell us what this stands for, isn't it? Yeah, we want to maximize an objective function, which is represented by $20 from B and $40 from S. We want to maximize that. Okay. The third step. Step number 3.
Establish constraints.
Excellent. We have got 3 constraints, not 3, 4. Right? One is material, which is the ash. The other one is the labor. Okay. Then the other one is the demand. Demand for P. And the other one is what? Demand for S. People, these are your objective function. So we're going to set them up here. This is ash. Okay, and this is the hours. Now, let's go, people. Let's establish the constraint within which we must operate in relation to each one of these materials. Let us establish. So we start with the ash. Who's going to help us there? Who's going to help us with the ash? We must operate within how many units? 5,400 kgs. So what we are going to spend on P plus what you spend on S must be less than or equal to what? how much ash goes on a P in terms of kgs? How much is that? What of there?
0.270.
Excellent. What of labor hours? You must operate within how many labor hours?
0.5. And
The total, how much do we have in total first, Valodia? In total, how much do we have?
Okay, in total,
Yeah, we have how many?
12,000.
Yes. Now we can come to the coefficients. How much labor hours goes on a P?
0.5.
Good. And how much goes on this one?
0.75.
Excellent. There we are. Now here we have established our own, meaning that in the exam we shouldn't have a challenge, because if you are now given these constraints, you're asked to explain, you can explain them comfortably what they mean. Okay. Let us go to the next one. Demand for P. There's a limit. You cannot go and on producing P because the demand is limited. So what we produce there must be less than what for P? Let's go. P must be less than or equal to what?
15,000.
15,000. Well done. What of S?
12,000.
Yes. I hope all of us are happy with what is happening here. And there's the non-negativity. We don't go into negativity. So here we talk about the non-negativity. We cannot go into negatives. So we are saying that cannot go into negatives. Our solution can't go into negatives. So P and S are greater than or equal to 0. That's a non-negativity. So you see, Jess, we can ask you, we can give you this and we ask you to explain, tell us what all this means. That is what your current exam is all about. After this, we draw the graph. After drawing the graph, then we come up with the feasible region. The feasible region. So now, let us come up with coordinates. Step 4, we are going to say we want pairs of coordinates. We want pairs of coordinates. So let us start with the material. We have P and S. Okay? If this is a 0 and that is a 0, what does that mean? If I put a 0, now some of you put a 0 where necessary. If I put a 0 here, let's come here. If I put a 0 there, here, I put a 0. 0 multiplied by 0.27, this will disappear. So what will remain is this one. So we've got it, 0.27 is equals 5,400. So divide this side by 0.27 and this side also 0.27. Now you see a good thing with the Excel, we just go 20,000. Again, if I put a 0 here, this will again be 20,000. Let's go to labor. Labor. Again, we do the same for labor. Let's go. If we put a 0 on P here, what will S be? If you put a 0 on S,
10,000.
good. If you put a 0 now this time on S, what will this be? We don't even need to calculate that. My team, is this okay? My team, is that okay?
Yes, sir.
Yeah. Okay, there we are. So now we can plot this. Now, when you get your graph paper, normally students have a problem with the scale. How do we scale this, Ms. Peel? How do we come up with a scale? The scale is determined by these values. What is the highest value here that we have? You have a 24. You have a 24. That's the highest value. So you want a scale, you want your axis to show a 24. Are we together? That's how you get the scale. So if you are drawing on a graph paper, you want a 24 to appear. Okay? So then, how are we going to, what values are we going to use? What values can we use? So we can throw away the zeros, we say 24. So when we are drawing now, what values do we want to use? Each grid should represent how much? 5? Or do you want us to go into tools? What do you want us to do? My team, I'm waiting for you. What do you want me to put here? My team, what do you want me to put here? Valodia, what do you want me to put?
Sorry, I didn't get the question.
Oh, in terms of the scale, I was looking for scale. I say, what values should I use on my scale here?
Sir, just a moment. I'd like to ask, is under labor, is P on the X, okay, in general on the graph, does P represent the X-axis or Y-axis? All right, thank you.
Sorry, I went off. Hello? Hello?
Yes, sir.
Oh, sorry, I went off. My mic was muted. Okay, so I was saying that tomorrow, let us meet to conclude this question. This afternoon, I want all of you to draw this and find the optimal operating point, find the number of units of P and S to be produced, and the total contribution to be earned. Again, to repeat that, please, this afternoon, all of you draw the graph, find the optimal operating point. Once you draw in the ISO contribution line, you push it out, extend it out, and the last point to be touched on these, the last point to be touched on this, that is your optimum operating point. Once you have the optimum operating point, you read off P and S, and then give us the total contribution. Tomorrow at 12:30, we want to meet. It's not our usual day of meeting, but we want to expedite to close this linear programming. So tomorrow at 12:30, please, can you log in so that we close the issue of linear programming? Is that okay with everybody?
Okay with me.
Is that all right with everybody? Log in tomorrow at 12:30. Please log in. We want to come and finish off this story tomorrow. As you come, make sure you have also tried the question. You have your total contribution. Okay. The only person who will be excused is Brenda because she's still catching up. But for the rest of you, please, you must tell me what is the total contribution from your optimum operating points. All right, so please, I'll see you tomorrow at 12:30. Remember to log in.